just tell me if you're able to follow the link. So there's the first very basic question about if you know basics about what artificial intelligence and machine learning is. So that often may sound kind of fun, but okay, you'll see in 5 minutes. In 5 minutes, the result. Oh, I see some people coming. We haven't started yet, but we already started to start. So before our lectures, we suggest you to answer just some introductory questions. And here is QR code with a link to the first one. Just use your phones and check the most appropriate answer to you. And for those who are late, let me just remind that today our topic is AI testing. And this word is usually used to have two different meaning. The first one is to denote AI methods and tools applied for software testing. And that will be the topic of our first lecture by myself. And second, probably even more promising and interesting topic is how to test AI system. Again, it's called AI testing. So you know that currently a lot of AI is around us. Artificial intelligence decides about our mortgage. It decides about okay, what to buy, what to read, and a lot of questions. So it's really important to be sure that these systems at least don't have much bugs. So the second lecture will be on how to ensure quality of AI-enabled systems, or sometimes they call it AI-based systems, so systems which have important modules with artificial intelligence. So the first question, I assume you managed to follow the link. Okay, let's see the answers. Can you help me to switch to no, with results? But I assume it's already open. Try again. So just yes, I see the window. Okay. So the first question was, what is your level of understanding of artificial intelligence and machine learning? Okay, and the most frequent answer is I already heard this buzzword. Okay, good. So at least we got someone who has some experience with machine learning. Okay, let's wait for 1 minute more. Maybe someone else arrived. So, but still, the most frequent answers is I already heard, but doesn't mean that I understand something. And the second one, frequent, is close to 0, which means okay. So, but it's okay to know the truth that almost no one understands what artificial intelligence, and that makes my lecture even more useful, I hope, because in my lecture we speak about very basics, some basic definition and basic notion. Okay, let's can you show me the magic combination how to return back? I've written the quad. Smart device. Okay, and then switch to question 2. Okay. This is QR code for the second question, and again, I suggest you maybe a couple of minutes to answer. And I assume this is a link to the question in our YouTube channel. Okay, let me try myself just to push the result. Okay, so the question was, which of your life critical decisions are you highly likely to delegate to a computer, a machine? So, okay, you see kind of different life situations. So one of them is, for example, deciding the country to relocate to, or deciding on major medical procedure you need to go through your relatives. But okay, some people may use machine learning to choose a profession or a university to attend, and maybe even a partner for dating or relationship. So different options. We assume that it is something you are willing to delegate. So this question is, what would you delegate first? And okay, funny. Yes. What, me? Yes. Ah, okay. Okay. But you know, no one choosing this option, but I would ask computer to help me with my future profession. Yes, that was always very difficult for me to decide, because a lot of interesting stuff. You can be a spaceman or movie star or maybe singer or stand-up guy. Actually, I had this option for me, and maybe an engineer or professor, or maybe just some. Also, I really like archaeology, just dig into some bones. And so it's really difficult to decide about future profession. So probably, but most of people okay is make. But for me, the first option, I mean, the one which is more frequent, is kind of no, because my food is my choice. So I would never delegate choice of the food to. Okay, maybe in some cases you're kind of in your city and in your restaurant, and I have no idea about all these titles, whether this food which is made of, etc. Then in this case, I'm probably delegated to a machine. But otherwise, food is okay, it's very personal. Okay, medical procedure again. I understand people because I understand nothing about medical stuff. So probably if computer decides the guys for you, maybe I would agree. And number 3 is the choice of, okay, someone already chosen. The choice of apartment. Yes, apartment house, it's another issue I would easily delegate because I travel a lot. If you go just to kind of another business trip or vacation, then since I already have quite a big history of different like successful, not very successful stays, then computer probably can decide which will be good for me. For example, I like to have some nice park not far from my apartments, but I don't care about like whether it's like another 10 minutes distance because I prefer walking, etc., etc. So I would easily delegate choice of apartment to some new new options, but again, the order is actually the same. Okay, let's switch to question number 3. Yes, so number 3. And also I ask our colleague to put the link to our YouTube channel here. So, no, the same thing. It's almost the same. No, it's slightly different. It's very similar, but slightly different. So, did you notice the difference? Yes. Yes. So the first question was about what would you delegate first. Yes, and this is what would you delegate last. So no, this kind of my last resort. I would never, because otherwise, kind of, it's computers which could decide about my life. Again. Okay, so I hope you are having fun. So don't treat it too seriously. Okay, so did you get the link? Okay, can you switch back to the results? The link is the same. You mean which was the first? You see, the second is the same. That's fun. So people are not likely to delegate selecting a partner to a machine. Strange, why? So you believe you know yourself better than machine. But guys, you mean we're wrong. Okay. Machine definitely knows you much better than you yourself. Yeah, but machine knows everything about your feelings. So okay, so you would rather postpone the decision, but maybe next generation will be may have different ideas. Okay, let's wait maybe for one more minute. But you see, only 44%. It's less than half. So it's kind of okay, but not that definitely. So quite many people would be okay just to ask machine for an advice and recommendation, even such a serious question. Yes, please. Okay, the same for myself. Last. Maybe food, but that's already a kind of comment that will not go, because everything else. Okay, I'm rather pessimistic if you speak about this question. So I believe that in every critical question, machine is more efficient, is more wise than a human. So I would delegate everything. So, and now last question, number 4. Before we start. So, question number 4, and I ask guys who are managing YouTube to paste the link into the chat. So people can go and answer question number 4. Again, it's slightly different. And okay, maybe a little bit more serious. But again, just it's fun. Don't be too serious, because otherwise it's kind of depressing to think about this stuff. Okay, can we switch to the you know, it's not the first time I'm asking this question, or maybe a similar one. It turned out that in every audience, people who are in this audience never think themselves as kind of responsible. Definitely, it's not we. For example, you're speaking to researchers, if you say, oh, no, definitely it's not we who are responsible. We're just doing research, we're just publishing our papers and doing like open source stuff for kind of best of humankind. And then surely, okay, algorithm developer, no, no. So, and then guys who are doing business say, okay, we are just doing business. We have all these regulators and politicians and different rulers who kind of should think about all this safety. We just follow the rules. We just create some nice cars for you to use. And okay, you pay us money, we give you this product, then it's up to you how to use it. We are not responsible, never. So the manufacturers believe they are not responsible, then definitely government never think it's responsible. Because guys, we just created really perfect laws, but you don't follow these laws. So surely it's not we who are responsible. And the car owners, they're just ordinary people. I just took this car and I just pushed this button and suddenly accident happened. It's not, definitely it's not me who is responsible. And probably they all together would blame the others. It's school and parents. Because they didn't teach you to read the manual. They did not teach you to follow the rules. And probably the worst guys are all these influencers from social media who just showed you the bad example. So no one considers himself responsible. So you believe that algorithm developer. No, but again, it's less than 50%. So you believe QA is responsible? Okay, QA is just part of a manufacturer team. So they are kind of, you know, it's really difficult to, at least that's what was I told about QA, that the product manager is responsible for the quality, I mean, for the system quality, because this is the guy who decides about how much resource to allocate for testing, how much, which bugs have better, higher priority and which have lower. So it's not only QA. QA just informs about some bugs, and definitely every system which we have in production has a lot of bugs. So it's actually the manager who decides whether it's enough to test to go to production or not. So it might happen that QA informed about all the situation, but business people decided, okay, we don't have enough money, and the budget is already kind of exhausted, so we just ship the product. So QA tried the best, but no one was interested to follow. Okay, so this question probably is the most provocative, and I don't expect that we have already kind of final answer, but at least to encourage you to think about all this stuff, that this is really becoming more and more kind of. So if you look at the previous question, then you understand that AI systems are becoming more and more involved in all our decisions and everything. And on the other hand, kind of no one is ready to take responsibility if something goes wrong with this AI system. So again, quality is the issue. And okay, that's why we have this meetup on AI testing today. Okay. start our. Can I just switch to my slides? Rostislav presentation. Yes, you can close this. Not this one, not this one. Yes, you can close. And this two. Yes, and again, if you think about previous question, so my question number 4 was about autonomous vehicle. But for example, replace autonomous vehicle, for example, with a system which recommends you a partner for dating. And then the system has a bug, and then you would like to blame someone that recommendation was not perfect. That's kind of funny situation, but okay, maybe quite realistic. Okay, so yes, so we start in our first lecture, and I'll speak about AI for testing. And let's test. Yes, it works. So although the title is about artificial intelligence, I will speak mostly about machine learning. It's actually very similar, but not the same, because artificial intelligence is quite a more wide topic. But at least today, most of people who work on artificial intelligence are focused on machine learning. And I like this picture because it's a very nice map on what we have in machine learning. And you see there are 3 areas. The first one is left upper corner, which is called unsupervised learning. And basically, it's the simplest way to start with machine learning. And then the second is more advanced. It's called supervised learning. And then you see also here the most typical application. So unsupervised learning usually means either clustering or dimensional reduction. That's okay if you don't understand some words, but gradually you will. You might kind of focus on clustering first. And supervised learning is mostly about classification, regression, and application of those 2 different practical tasks. And the most advanced, the most kind of technically difficult field is called reinforcement learning. And it's still kind of under development. But on the other hand, it's the most promising. Many people will believe that with the reinforcement learning, we will be able to solve any task, and the computers will become smarter than people. So my first part of my lecture, I try to shortly explain every idea on this slide. So let's start about machine learning areas. And I mentioned the first is unsupervised learning. And the scheme is very simple. It's called unsupervised. It means that the machine works alone. So just get some data. Okay, it's written on the left. You see some box with some dots. So any data you have, you just feed to some algorithm. And then as a result, you get some analysis. So definition, a machine learning technique in which the user do not need to supervise the model. So everything is done automatically. Okay, it's not really automatically because as usually you have like, you know, do you remember this photo of plane drivers? You have a lot of configuration turn and off on, and also usually this algorithm have a lot of configuration parameters. So you really need to understand what's going on to configure it in the best way, but otherwise the algorithm doesn't require any additional human effort. So you start with some data, you run the algorithm, and you get some patterns. And the most typical example of patterns is if you have some object quite similar. Okay, similar is more or less informal word, but the clustering makes it formal. So for example, on this picture, initially you have some black dots, and then after some application of clustering procedure, the computer decides that actually your set of values, set of your data set could be reasonably divided into 3 different groups, like green one, blue one, and red one. And that's quite important information because later you can deal separately with each of these groups because they are kind of more or less similar. And here is the list of possible applications of this algorithm. And for example, audience segmentation. For example, currently you are watching my lecture online on YouTube, and I know nothing about who is watching. But by collecting some data about, like, okay, surely I don't have much information about everyone who connected, but for example, we are kind of a channel and you connect regularly, and for some of our videos you just push like button, for other you don't. So I already have some information of you. So by running this clustering algorithm, I can divide my audience in several groups. Like this, okay, this group likes very simple introductory and short videos. The other group prefers kind of more advanced and technically technical videos, and kind of the other group, like again, green, blue, and red, is smaller than the other one, but it likes doesn't care about length or technical advance. But this group prefers video which you recorded on Saturday and Sunday, for example, for some reason, because they have just a lot of stuff to do during the week, and they prefer. So you see, there could be. So since it's unsupervised, the machine just does it automatically without any understanding of the domain. So it may happen that the classes are very irrelevant. But anyway, this is already information you can deal with. And another example is customer service personalization. For example, you come to a bank or telecom company, and then by the data you provide, the company decides, okay, our algorithm decides that you look very similar to all these teenagers who don't need something like extensive traffic for work, but they prefer a lot of time for like Facebook, Instagram, etc. So we suggest you some personalized plan which has this and that kind of included, but the other part is kind of more expensive. So, and this is done by clustering algorithm because you are kind of allocated to specific cluster, and then on base of this decision, the computer decides kind of something specific for you. Okay, then recommended engines in other similar example. Anomaly detection, we'll speak about more about it in 10 minutes, but you see that, as I mentioned, some class may turn out to be rather small. So you may not notice that, for example, all your audience consists of kind of 2 huge parts, and then some strange third-party piece which consists of, for example, 3 people at most, and they are kind of regularly add some negative comments to your, so they're just roles. And again, clustering technique could be quite useful to figure out these guys because their behavior is different from the others. So they're kind of anomaly in this case. Then pattern recognition, inventory management are another examples of this unsupervised learning. Okay. And the second part of the picture, it was on the right. It's called supervised learning. And the idea is that you have additional step. So before you run your algorithm, you provide it with so-called training data. So you start with labeling, and that's really kind of time and resource consuming because, okay, the numbers are different, but usually to train your system, you need at least 10,000 data items labeled. For example, you need to teach your, okay, the most typical example, to teach your computer to distinguish cats from dogs. Then it would be kind of minimum to have like 10,000 different pictures, and each of them should be labeled. Like here we have a cat, and this is dog, and this is another cat, and this is another dog. Then this training data set is used by the first phase, which is called the model construction. And once this model construction is completed, then the computer automatically can decide on new picture, whether it's more like dog or more like cat. And it's quite clear what's going on. So it tries to match this new data to the list of labeled data it has. Like you had, so this look like this cat or more like this dog, and you know that some cats are more like, like dogs and otherwise. So it computes some distance and finally decides probably this is cat or this is dog. So, but again, this algorithm are very useful in applications. But before starting, you need this training data, and then algorithm extracts this features vector, and then trains, and then creates model. So, yes, this example was just mentioned. So you have like pictures of cats, dogs, or chickens. Then you create this labeled data set, and after the model is trained, provided unknown picture, the supervised learning algorithm decides if it's more like a chicken or a cat according to some features. For example, feature could be something like size of an eye, or maybe color of some, okay, whatever. So different features are used for this classification task. Okay, and this is the list of possible applications like healthcare and medical diagnosis. So it's rather clear. So typically, you need a professional doctor which looks at your like kind of data to decide, okay, maybe this disease or another one. And this is a very good example where you can apply all this supervised learning. So providing is some huge data of which is labeled. Then at some point, computer can decide better than a doctor. Then some questions? Yes, please. So the question is whether we start with supervised or unsupervised. You know, first of all, it depends on the task, because some tasks, surely it would be better always to start with unsupervised, because you just spend maybe a couple of hours by configuring your algorithm, then you push the button and finally you get the solution. But for many tasks, it's impossible. For example, you cannot distinguish cats from dogs by just unsupervised, because the differences would be very, so it depends on the domain. And okay, weather forecasting, text categorization, spam is another good example. But again, formally, it's very difficult to distinguish spam message from kind of regular message, because the guys who write spam are very creative. But providing your algorithm is like 10,000 examples of spam message and not spam, at some point, following different features like whether this message is short or small, whether the address is kind of your frequent friend or something else, whether it uses these words which usually people use in your company or different words, whether the grammar is the same. So the computer extracts a lot of different features, and then on base of these features decide whether it's more or less like spam or not. And surely in this example, you need to retrain your algorithm regularly, because once you manage to distinguish spam from not spam, the spam writers realized it, introduce some new ideas. So you need to update. And then again, face recognition, it's another example where this is truly the example where you cannot do anything without training. For example, how to tell that it's really me. I mean, to face recognition. First, you need to provide an algorithm at least with a couple of photos of you to say, this is my photo and this is another my photo. It's better, the more the better, but at least one is definitely necessary. And then the algorithm uses this photo to train, and then to say next time, okay, there's a guy who tries to enter our club, is definitely our club member, but this other guy doesn't look like. Maybe he has to save before entering because he doesn't look like the one on the picture. Okay, so you see these examples, and they are kind of slightly more technically difficult, but this is where current kind of state of the art of machine learning you have here. So, and the third part of this picture is about reinforcement learning. So you see this picture. So on the right hand, we have this beautiful, big, complex, unknown world. And on the left, we have like tiny, small, and simple algorithm or robot who tries to understand this world and to not just to understand. You see the difference. I mean, in all the examples which we had before, usually the computer has quite simple question, whether this is a cat or dog, whether this is sperm or not. But here, the algorithm needs to behave somewhere in this system. For example, it's about robot navigation, about different examples where the world is changing. So you cannot just decide once for all that, okay, I will always turn right when I on the kind of crossroads, because sometimes you need to turn right, sometimes you need it's not allowed to turn right at all. So you need to learn from environment, and here this is the loop. So the loop starts that from that the agent creates some model of the environment about the world, about its state, and then it takes some action. But once the action is taken, the world is changing. So now the world is different, and the state is different. And the basic idea of machine learning here to introduce this reward system. So when the move was correct, then you get some kind of plus something in your algorithm. And when the move was incorrect, then you get some minus. And this is probably the simplest example is from gaming industry. For example, you try to teach your algorithm to play chess, or maybe Warcraft, or maybe some other fancy game. So this is kind of the best example of using this reinforcement learning, because the algorithm analyzes the scene and tries to do something, and when the move was wrong, then it's kind of killed. So it decides, okay, that's probably not best move in this context. next time I will try something else. So after like 10,000 at least different iterations, the algorithm starts to behave quite smart way. Okay, at least we perceive it as a smart way, but actually it's kind of the result of a lot of iterations. So, and here is the list of most typical applications of reinforcement learning. One is definitely self-driving cars, because it's exactly what we have there. So you control your car, but every second, wow. Yes, let's wait for, yes, 5 seconds is usually enough. So, I hope, probably you need to somehow to connect this, no? This one also works. So we continue with self-driving cars, which also called autonomous vehicles, just to indicate that it's not always cars, it could be some helicopter or underwater drone, whatever. But the logic is the same. So the computer needs to build a model what's going around. Then based on this model, it makes some decision. But after this decision, the situation changes. Since we turn the right, now we have different picture what we see, different traffic, different everything. So we need to rebuild our model of the environment, then redesign, decide again what should be our next move. And in some cases, we get kind of positive reward. So this was really good move. So we are okay. We are not killed at least. And in some other situation, we get negative. And it's very similar to how people learn, right? So through your life, you get into some positive scenario and you just feel happy, but usually we learn from negative scenarios, right? And that's what's going on here. And yes, another example is natural language processing for chatbot dialogue. So you buy a system with, for example, like a Siri assistant, and this system surely it's pre-trained by manufacturer, but in order to become more like more perfect, it gradually learns about your style of speaking, about your specifics, individual like different features. So it's another example of reinforcement learning and dynamic treatment regimes in chronic disease. So you see it's more advanced version of machine. So the computer don't just decide about what's happening with you. It suggests you some treatment, and this treatment evolves with your kind of change of state. So for example, day to day, you're kind of becoming better or not. Then the system decides what maybe update to your treatment is required on this according to this new state, new environment, new model. But as I mentioned, okay, that's exactly what's here. So returning to my picture, simplest to apply is unsupervised. So you just take algorithm from the shelf. Okay, this is already it's model, but you can see the difference, and you can already use it for customer segmentation, target marketing, or recommended systems. The other part is slightly more advanced. It's again more powerful, but it requires some data labeling in the beginning. So you can start before you label data: cat, dog, good, bad, spam, not. And the third part is the most advanced, but again, it's most promising. So that was with my first part. And then, as I promised, let's speak about software testing, how to apply everything I mentioned to the task of making your system, your software more high quality. And there are kind of four applications. The first, most straightforward, is about anomaly detection. And typically, if you're speaking about complex system, you can't specify every behavior, right? For example, it's like network infrastructure, or like even simple application can be not that simple inside, because you have many threads running inside with different race conditions, asynchronous calls, etc., etc. So sometimes you feel like everything goes on, but system behaves something kind of suspicious. And this is exactly the goal of this kind of algorithm, to detect anomaly. And if you look at this picture, you see all this. So assume we have kind of two different parameters. One is X, another one is Y. And we have all these red dots on this plane. And you notice that blue one actually is kind of okay, because the first parameter is kind of acceptable, and the second parameter is also is kind of acceptable. So it's not that easy to figure out that this blue dot is anomaly. But the clustering algorithms are very good at this. So they realize that most of your data is in red cluster, and then you have another cluster which consists of just one point. Then it's clear indication that something is wrong with this particular instance. And this is actually the definition, that anomaly is something that differs from a norm. So it could be deviation, exception, some rare occurrence, or anything that seems suspicious. But in order to figure this out, you need some definition of what norm is. This is the more difficult part, because until you explain the computer what's the norm, you can say, okay, this is not norm. So, but anyway, this is what we can do without labeling in advance. So this could be done by unsupervised learning. And the most typical example is log analysis. So this is a very simple example of system log from Ubuntu. And this is how typical log looks like. You see some timestamp, right? Then some module definition, and then some message. Sometimes just info message, sometimes it's warning message, maybe some exception, but okay, exception which you're caught and dealt with, so it's not necessarily crash. So you have all this, and usually you have like terabytes of these logs, right? And it's not that easy to figure out that log we have today is slightly different to what we had yesterday. And situation is even more complicated because notice timestamp here is actually the same. It means that all these events that we actually don't know the order about these events because they could come from different threads, from different modules. So it may happen the order in which they happen was actually different from the one we have. So logs are really not easily clearly not that easy to analyze, but anyway, that's where unsupervised learning is good. So usually this model which defines which is okay, which is not okay, is built on the base of historical logs. You study the history. I mean, not you, but the algorithm. It analyzes the history and decides which behavior is kind of standards. And then on the basis of this model, it detects different types of anomalies and different statistical characteristics. And the second bullet is kind of more advanced research with application project. Some people try not just to analyze statistics, but also the context of different messages in the log. For example, yesterday this message appeared between this and those, but today it appears in different context, and that could be kind of suspicious. So different techniques could be applied here, and this basically is the first example of applying machine learning to system analysis. Okay, let's see some examples here. So picture on the left provides us some numerical ideas of what could be the outlier, the anomaly. Because again, in my first example, it was simplified. We had just one blue button. So everyone is red, this one is blue, definitely it's okay. Surely this one is anomaly. But in real life, you might have like picture like this. So actually you have like 95% of your data are okay, but the other 5% are kind of suspicious. But again, 5% is too many. You cannot analyze this, so you need some numerical values to at least to decide that this is more suspicious, this is less. So again, there are some techniques how to measure this. And the other pictures I also like because it provides you with example of anomaly. You see this graph on the right upper corner. So everything goes more or less periodically, and at some point you see this outlier. But again, for us humans, once you see on this picture, you can easily decide, okay, this is kind of standard behavior. But for computer, it takes really some time and some technique to figure out what is model and what's not within the model, and sometimes it could be quite tricky. Okay, let's switch to the second example. The second example of applying machine learning and artificial intelligence is to analyze bug reporting. So once testers find the bug, we just submit a report. And as a matter of fact, each of us, okay, most of companies are now international. And for some people, English probably is native language, but for others it's not. And some people speak different English, actually. So, so the first application of machine learning is to check the readability of the bug report, whether this is what you've written is really that people from different cultures really understand it the same way, and that's what we can do in machine learning. Then another important feature is duplication detection, because again, typically a huge system is kind of which is on the market like for 10 years, it may happen that you already have like 10,000 bug reports in your system. That's not a big number. And then you as a tester found another bug and you try to report it, but you do it in your own words, surely. But it might happen that bug number 2035 is actually very similar. Okay, it's not the same, but very similar. So the system has to decide that according to text, to description, this is actually the same bug. So to figure out that you don't need to submit another one, just maybe to update this one with some new scenario. So duplication detection, then another field like fault localization. Again, your system usually consists of like dozens, maybe even more hundreds of different modules written by different developers, maybe in different countries, even different companies. and you need to allocate this bug to someone, whether this guy has statistics or the other one. And sometimes it's quite clear, but sometimes it's not. And sometimes there are quite interesting situations where the bug is kind of between modules. For example, they have not decided about interface. So each of them can claim that, no, we are correct because we have this kind of specification, and the other guy, no, specification is really different. So it's not that easy to allocate the bug. And finally, the machine learning, and we had this kind of project with our company too, could be used to predict how much time it will take to fix the bug, which is severity of the bug, etc. So another area of applying AI. And number 3 is, yes, this is another very quite promising and interesting topic. The idea that usually bugs come not from developers, but from the guys who write requirements. Because if your requirement is incomplete, is not precise enough, then you could be sure the developer will understand it in different way. If it's kind of, and especially if you have kind of incomplete specification of some interface, then one group of developers who depend on this interface will interpret in this way, the other will definitely interpret in different way, and that will be realized on the late stage of your product lifecycle. And it would be very, very costly to fix it. So it's very promising to apply machine learning techniques to find these linguistic issues in your requirements documentation and to check whether the information provided in your docs are sufficient enough. And if you go even further, some people try to build tools which will automatically generate tests from your specification. But for that, you need to convert kind of natural language description into formal description. So that specification is more already like a code or maybe like UML diagram or whatever. So once it's formal, then you can feed it to computer and build some tests on the base of the requirements kind of immediately. And yes, that's kind of different research directions. And just to conclude, it's more like fantastic idea, but we already had some paper on this topic. The idea is, okay, but the idea of a virtual assistant still was fantastic like 5 years ago, right? Maybe 10. So someone artificial would like say you good morning, your what your favorite music for today, etc. But now everyone has a virtual assistant from Google or from Amazon, and the idea is to make artificial assistant of tester. So it's kind of like usual your junior like assistant. You come to your work in the morning and you ask questions like, okay, hi, okay, we haven't decided about the name of this assistant. Hi, assistant, what's new about our overnight tests, and what was a major kind of what was different today from tomorrow, from yesterday, and okay, which models were kind of the worst, the best, etc. Again, this maybe sound like fantastic, but there is already a lot of research in this direction to make a kind of robot tester, because quite a lot of work could be done in automated or maybe semi-automated way, or just maybe some supervised learning, etc., etc. So this is basically it. My lecture. Thank you very much. Questions? Comments? So yes, maybe some questions from the web. And Iosif, should we make some maybe break? Okay, so we will have a break of like 12 minutes, right? So according to local time, we start at 7:15 p.m., right? So, and yes, we can grab some souvenirs. Even some food. Guys, we have some food there. Okay, so 11 minutes for food, souvenirs, and then we continue with the second lecture. You have a question? Yes, I check, but okay. Hello, hi, links, yes, sound okay, feel free. Okay, so far, food. Okay, thank you.
Good evening, everyone. Thanks a lot for staying with us today. And thanks a lot to Rosti for the first lecture on AI-based testing. My name is Iosif Itkin. I'm co-CEO and co-founder of Exactpro. And today I plan to cover a few topics. I would like to tell about Exactpro, about AI-based financial systems and their examples such as conversational assistants, chatbots, market surveillance systems, self-driving cars, certified tester AI testing exam, and about challenges of testing self-learning and non-deterministic systems. Exactpro is a company founded on Software Testers Day in 2009. We are a UK-based company with operations in US, Georgia, and Sri Lanka. We opened our office in Colombo last year in Parkland building, and it is currently growing. Exactpro employs over 700 specialists across our locations. We focus on AI testing, both testing complex systems using advanced methods and also testing AI-based, AI-enabled systems. Exactpro was part of the London Stock Exchange Group for 2.5 years. At the moment, we are an independent company following the management payout in 2018. Our management team and delivery centers are distributed worldwide in UK, Japan, US, Sri Lanka, Georgia, etc. We work with half of the top 20 global exchange groups, and we have clients in more than 20 countries, in Australia, in United States, in Greece, in South Africa, in UK, France, etc. There are lots of materials available online about Exactpro and our research on distributed ledger technology and AI. We are very proud of the projects that we deliver for our clients, in particular MEMEX, the fastest growing equity exchange in North America, Skytra, subsidiary of Airbus that uses platform from NASDAQ, Ledger Edge, delivered by software development house Yala Labs in Sri Lanka and based on distributed ledger technology from R3 and many others. Exactpro has lots of awards in operational resiliency and test automation areas. We built our platform to enable AI-based testing in financial services. The platform is in open source, available in GitHub. It is called Teach2. And we participate in various activities. In particular, last year, Exactpro data science team came second in large Swift hackathon on producing test data. This became second after JP Morgan. There are lots of applications for AI in financial services. A report from Bank of England and FCA highlight multiple use cases, including market surveillance systems, conversational assistants, algo trading, pricing calculators, machine-readable news, and insurance claims. As you might know, one of the best market surveillance systems in the world is produced in Sri Lanka. Market surveillance systems have to deal with lots of data with every transaction that happens in financial markets, and they have to deal with detecting anomalies related to information manipulation, to misleading activity, to watch trade, etc. Quite a lot of volume currently in financial markets are produced by algo trading. So market surveillance systems have to apply more and more advanced methods to detect signs of anomalies of fraudulent behavior. And that's why market surveillance systems apply more and more machine learning techniques, both supervised learning for alerts and also unsupervised learning to find patterns and anomalies in data. Another more common and more widely spread use of artificial intelligence is chatbots or conversational assistants. There can be task-oriented systems, there can be question-answering systems, there can be chatbots for entertainment, and there can be advanced applications that use a mix of all of the above to provide the service. What we found out so far is that even best chatbot vendors are not really ready to put their software to the test, because most of them are trying to prove that their chatbot just works. In software testing, we are trying to highlight that software doesn't work. And even the best vendors are very reluctant to expose their chatbot technology to the test. Probably due to many high-profile failures observed previously. The most notorious one, the well-known and referred in Wikipedia and a variety of other sources, is the TEI bot from Microsoft. TEI stands for Thinking About You. It was a research project by Microsoft team. They connected their AI to Twitter, and it was using responses and comments from Twitter users to produce response. And within 16 hours, the TEI bots, due to activity of internet trolls, started to post offensive and inflammatory tweets very frequently. So just 16 hours after its launch, it was shut down. But then inside Microsoft Research, they did additional testing, and 1 week later accidentally turned the system on again in production. So it proceeded with putting more and more bad tweets, and Microsoft has to apologize for it. But if we think about it, it is a very interesting event from research perspective. Personally, I think that it would be much better to keep the system up and running so we can learn from it. As they say, oh, it's very bad to have a racist chatbot tweeting tweets. But I would say that it is, there are worse things. For example, to have a racist self-driving car. So it would be much worse So we need to study AI systems wherever we can instead of shutting them down. Exactpro participated in self-driving car test automation challenge. Last year, we developed a course that is available on our YouTube channel. And it was using a simulator for the road produced by LG and autonomous vehicle driving stack from Baidu Apollo. This environment represents our motto, build software to test software. We can use a road simulator, a piece of software, road simulator based on Unity game engine to test autonomous vehicle soft. And we also can use autonomous vehicle soft to test road simulator. So in order to test something complex, we need proper instrumentation. And that's why we call it build software to test software. There are many interesting materials available on using data out there to improve testing. In particular, there are works related to using natural language processing to produce additional scenarios. One of the papers looks at the national database of car accidents in order to generate test scenarios that can be used with simulators at some point with real cars as well. And there are many interesting reports in the database, and some of them are already related to autonomous vehicles. This is one of the most famous examples. You are looking at a modified Volvo XC90. It was used by research in Uber technology for testing. So the car was riding through the test route, and a test driver in her instructions, she should have looked at the road, but instead she was looking into her screen, so she put her mobile phone just under the driver's console and was looking at TV series on Hulu service. And by the time a crash happened, the car was driving for 18 minutes fully autonomously. So there was a reason why a test driver never felt necessary to look into the window to control everything, because the car was driving by itself. And then what happened is there was a lady with the bike crossing the street, and unfortunately the pedestrian with the bike was under drug influence, so was not able to adequately monitor the situation. In contrast to AI in the car, AI in the car detected that there is something in front of it, but was not sure what it is. So first it decided that it is a pedestrian, then it is a car, then at some point it realized that it is on a collision course. In 1 and 3 seconds prior to the crash, AI determined that it needs to immediately slow down and push brake not just brake, but emergency brake. So AI itself gave an order to push emergency brake. But there was a problem in the software. And the problem in the software was that while using AI to drive Uber cars, engineers decided that if they will keep emergency brakes in place, it is possible that AI will result in some erratic driving. So because AI can make decisions quicker, then it can press brake more frequently and more unexpectedly. So to avoid problems for the test drivers, they switched off emergency braking in Volvo car. And what we can see here is that no matter how advanced or correct your AI system, it is not usually used alone. So in AI system is connected to sensors and to actuators. So in a car, actuators is gas and brake pedals, sensors, various radars, lidars, etc. So if your sensors are lying to you, or if you are not able to press a brake, then no matter how good or bad your AI system, it will not be okay. Even for AI-based system, a crash course by Google on machine learning and production machine learning systems, they estimate that only 5% of overall software code is related to machine learning. Everything else is surrounding it. So what we can see in Exactpro is that quite a lot of work will go into end-to-end testing for the systems that are AI-enabled or AI-based. AI systems have three main features: ability to learn, ability to generalize, and their transformness. And ability to learn is studied in details. There are lots of papers. It is present in every tutorial. But ability to generalize is something different. It is end-to-end testing, something similar to what we do on a day-to-day basis when we work with complex systems like clearing platforms, trading platforms, etc. There are too many sensors and too many actuators that go into the system. And also, most of the modern financial applications are based on data. So there are tens of thousands of switches that guide how the trading or post-trade system will operate. There are certifications available, and it appeared just last year. It appeared before all these things started. I'm wondering if it will switch off or not. Cool. Oh. And the lights are on. Yay. Hello again from Colombo. It is what we do here, but when there is more rain, the situation will certainly improve, and it will improve in general. It will take us a few more seconds to get back. Switch there to okay, perfect. Thank you. So people are afraid of AI, and that's why they produce additional research, additional training courses. So now a new ICQB certification is available. It is called AI testing, ICQB certified tester, AI testing. It appeared officially in October last year. Prior to that, there was another certification available. It's a predecessor from A4Q, Alliance for Quality. I would recommend everyone to have a look into the syllabus for certified testers on AI testing, because more and more systems around us will be AI-based, AI-enabled, and that's why it makes lots of sense to study it and to understand better what can potentially go wrong. The creators of the syllabus and lots of AI research papers think that there are very specific quality characteristics and features of AI-based systems that make them different from other software. In particular, they use terms like and ideas of non-deterministic behavior, probabilistic behavior, and non-testable. So non-deterministic behavior is when you are not able to predict what will be the output based on predefined inputs. Probabilistic is when instead of giving yes or no, the system will respond with some probabilities. Example, a mortgage application, somebody fills in the form, and then AI system gives its response and provides this is the probability of this particular person returning the loan. And it might be more difficult to test such systems in comparison to those where you have a precise answer. Non-testable is when you are not able to say what is the right answer. For example, if we have, once again, a mortgage application and we enter the form and then it says, okay, give this guy a loan. How can we test it? So we do not know whether we can wait for like next 10 years whether this particular guy will be able to pay off his mortgage or not. And then we will find out. But the testing project will be completed long before that time. So non-testable is something that is present. Oracle is a very important concept in software testing. It is how we know that we do not see something buggy in the software. So Oracle is something that tells us whether what we observe in the software is okay or not okay. And the funny thing is that in AI syllabus, AI testing syllabus, Oracle term Oracle happens, appears frequently. It also appears frequently in context-driven testing school materials, but in standardized TQB syllabus, it appears very rarely. So in testing normal systems, people do not care about test oracles or something like that. If we look at low latency trading applications, for example, like those that are produced in Sri Lanka and other locations that are used by exchanges, brokers, banks, etc., what we will see that most of them are low latency, multi-threaded, distributed applications. And the main feature of the multi-threaded distributed applications is that it can take different time to get from one box to another. So if you send lots of messages into the system, you are not able to predict the sequence of the messages when they get into the trading core. It means that the behavior of such a system is non-deterministic. And for years in Exactpro, we were studying how to test such non-deterministic probabilistic systems and developing advanced test oracles for them. This expertise is applicable for testing AI-based platforms. AI testing syllabus put together list of challenges for testing self-learning systems, and these challenges are unexpected change, complex acceptance criteria, insufficient testing time, resource requirements, insufficient specification of operational environment, complex test environments, and undesirable behavior modifications. Once again, it is something that in Exactpro we have to deal on a daily basis. So all the challenges that are specified by syllabus as applicable to testing self-learning systems, they are of course related to any complex distributed system that we have to deal with. And that's why we in Exactpro and in our office in Colombo continue to develop more and more advanced methods of dealing with such kind of distributed complex systems and applying more and more advanced methods and platforms to deal with it. Quite a lot of materials are available on this YouTube channel, so please do feel free to subscribe and help us promote this material. I very much hope to continue organizing software testing event in Colombo, and thank you very much. That was the last slide. Thank you. Do you have any questions?
Go 3 slides back.
I like this slide. Okay, great.
Yes.
This one.
Can you just say a couple of words about the last item? Undesirable
Undesirable behavior modification.
By whom modifies behavior?
Wow.
Do you mean the user or the developer?
It can be, so it's an undesirable behavior modification. I think whoever tried to put it, they were thinking that the system behavior will change as it experiences more data, and more data is accumulated in the system, and it will result in undesirable behavior modification. But once again, getting back to the world of normal systems, it also happens there. So years ago, one of my colleagues, let's name him Stefan was working on a task tracking system. And we were developing load tests for that system. And what we found that under load test, the system starts working slower and slower and slower and slower. So its behavior changes. Then it appeared that for some reason, we assigned all tasks to a single user. So it appears that in the system, we have 99 users without any tasks, and one user that has like 10,000 tasks assigned to them. So even without any machine learning, you can achieve dramatic, undesirable change in behavior due to the data that you put into the system. And that's why studying non-functional testing, performance testing, is a very good way to prepare yourself to work in AI world and AI-based related testing. Thank you. Thank you very much. Do you have any more questions? Sorry? I'm afraid of this screen. No, we do not have any questions online. Thank you everyone for joining us today, and we very much hope to see you soon. Thank you. Bye.